Welcome to episode 241 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
All right, Rob, how are you doing?
I'm doing okay. For listeners who are watching the video for this one on YouTube, I am in a different room than normal, just to get myself better set up for the next few weeks. I'm up in my guest room, so I can have this room to myself instead of sharing it with my wife and kids.
You might want to get something other than backlighting if you care about the video because your face is really dark.
Yeah, I do have a light in here, but the window is still letting in some light behind my head and making it a little dark on me. Yeah.
I can make my lighting a little better, but then I just blind myself, so I'm not going to bother with that.
Yeah, maybe I'll have something better for next week. Anything okay? Everything okay with you, though?
Yep.
That's
normal life here, pretty much.
Okay. Well, at the top of every episode, I'd like to read a piece of feedback. This week, we got tweets after last week's episode with Cy and Kevin Cadu from Microsoft. And Patrice Roy tweeted that Kevin is actually one of his ex-students, and he now officially feels old. And Kevin replied, Patrice is one of the best C++ teachers he ever had, if not the best. And I just thought that was nice to see, and I didn't think to ask who his teachers may have been, but maybe anyone who was like from Montreal. We should ask them if they know Patrice Roy.
Probably.
Yeah. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Daniela Engert. Danny has a degree in electrical engineering and has worked for more than 30 years now in the development of a wide variety of software and hardware projects, mostly in the domain of digital signal processing and its application in areas like signal and communications intelligence, medical imaging, and now industrial non-destructive testing of steel goods. Danny, welcome to the show.
Hi, Rob. Thanks for having me. And hi, Jason. Nice to meet you again.
What that really caught my attention there, industrial non-destructive testing of steel goods. What does that look like?
Well, actually, the project that I'm working mostly on is inspection of railway axles. If you know, the high-speed trains, quite popular in Germany, have very special axles which have a bore going from one side through the core to the other side, and every 100,000 million or a million of kilometers, they need to be inspected for cracks and flaws in them. And of course, you can't cut them in two pieces to find any kinds of flaws in them. But we use both eddy current and ultrasound probes, which we stick into the bore, and from the echoes coming from the outer surface, cracks or flaws, we can determine if the axle is still fine to run for maybe another million of kilometers.
Wow.
And this has to be done quite regularly. So this is one kind of steel good that they are doing machines for. The other one is steel plates in steel plants, steel mills. For example, if you have a steel plate 20 meters long, 4 meters wide, and 30 centimeters thick, we can look into these steel plates and determine if this plate is good enough to become a pipe or something like that.
Interesting. So how much?
And other quite popular product of ours is inspection of bearings, the big bearings, for example, for windmills and this kind of stuff.
Oh, okay. Does it do these like ultrasonic probes and whatever, do they generate like a lot of data that you have to analyze?
They actually do. A couple of years ago, I've been developing an ultrasound device for this kind of inspection, which would generate at the AD converters about 1.5 gigabyte per second.
1.5 gigabytes per second. Okay.
Gigabyte per second, yeah. 16 A to D converters and then an FPGA behind it to condense the data a little bit and then putting it over a USB free line to a PC and processing it over there.
Oh, that's fascinating. So you have to do the FPGA for pre-compression so that it doesn't saturate the USB connection?
This is right. On USB free, you get about, well, actually I achieved 350 megabyte per second. So I had to condense the data down from 1.5 gigabyte down to 350 megabytes per second, and this is what the FPGA was doing. And I did the whole stuff from the analog digital design, the FPGA design, the communication protocol, the device drivers, and the application program.
Wow.
This is the stuff that I really love to do. This is application of digital signal processing.
I'm even more curious now, like, because I have no idea how hard it is to implement something like that in FPGA. Are you doing like complicated compression algorithms like bzip, or are you doing like RLE or something just to get it down to what you need?
No, this is not that kind of data compression that I used to.
Okay.
It's actually you throw away data which is not interesting. For example, if you have a certain bandwidth that you're interested in and you throw away all this stuff that it's outside of this bandwidth of interest, you can then convert the data rate down to a manageable level. This is the kind of stuff what the FPGA is doing. This is stuff called linear signal processing, where you just pull out the part of the sample data which is really necessary to find the flaws in the steel goods.
So compression more like from a signal perspective than from a what I'm thinking of file compression.
Actually, yes. This is exactly what this FPGA is doing.
Wow. So how long have you been working on that project, if you don't mind?
A couple of years.
Okay. And it all works now.
Well, actually, it does work, but it has a couple of flaws in there. And we have a contractor which was supposed to implement my design into the FPGA. And this contractor, well, let us down a little bit, so this product is not yet in production.
It's unfortunate.
Quite unfortunate, yes. But at least now we can do it on Windows 10, so the USB connection is much better than on Windows 7.
Oh, that's good. Delay the project until the software catches up.
Yeah. Sometimes there's a really good thing in bad things as well.
So just out of curiosity now, since we've discussed this, do you know how many years or months or however long it takes for 1 million miles on one of these high-speed trains? Like, what is that? Or 1 million kilometers, I mean?
Oh, probably less than a year.
Less than a year. Okay. So that's probably, it means a lot if they can certify those and not just have to replace them on a fixed schedule or something like that. Probably saves a lot of money.
Yeah, this is true. And actually they try to avoid longer maintenance, because a train earns money only if it runs on and transports people or other stuff. And so this inspection has to be really quick.
Right.
So the inspection of a whole train should take no longer than a couple of hours or so. So you need specialized machines which can do that, and this is the kind of machines that they are building.
That's neat.
Yeah, very cool. Okay, well, Danny, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about modules, okay?
Okay.
All right, so this first one we have is static analysis in GCC 10. There's a blog post from the Red Hat developer blog, and it's all about a new F-analyzer option being added in, or was added in GCC 10. But you would be interested in this one, Jason.
I was, and I went all the way through this article, and I noticed a theme. I don't know if either of you noticed it, but throughout it, the author says, oh, with C code, and every single example is with malloc and free.
Yeah, I've been noticing it as well, and my thinking is okay, this is the kind of problems that I have never been experienced in the past 10 years. Now with C++, even without this checker.
I love the optimism, but what I noticed is that if you go into GCC and put it in C++ mode, it does not do these checks at all. You can write the exact same code and it doesn't run it. You have to put the compiler in C mode and then it will run these checks.
Even worse.
Yeah, what's the point of that? I mean, if it's the same code, why couldn't you run it in C++ mode?
I don't know, but there is a hint that at the top saying that once this gets more mature, it'll be enabled for other languages. Okay. Yeah.
Well, that's good.
So for any of our listeners who are writing pure C code, yes, use all the tools that you have available to you, including this new F-Analyzer from Gcc Ten.
Yeah.
I mean, it looks really good. The diagnostic flow that it prints and everything, it looks amazing. It really does.
This is true.
Yeah, there's some nice like ASCII charts to track, you know, what exactly happened with your, you know, pointer that you deleted twice or something like that, right?
Yeah.
So the question is, what took more effort in the implementation, these nice pictures or the actual analysis?
That's a good point.
That is a good question. Although I will say pretty ASCII really makes me happy. Like looking at something like this, I'm like, you know, that's like, that's pretty. I like that.
Okay. The next thing we have is this link for C++ Annotations version 11.4. And Jason, correct me if I'm wrong, but this website looks very familiar to me. So I think we have mentioned it before on the show. But it's been updated with C++ 20.
And I agree. When I first saw it, I thought, have we already talked about this before? Did Rob make a mistake?
No, I think we have mentioned it before. It's just been expanded with, you know, information about all the new features added in C++ 20. And it looks like a very verbose resource for explaining, you know, all the different features available in C++, including the newest version.
Well, actually, this document was very new to me, and I've been digging into it a little bit. And at least I read the first 3 chapters or so.
Oh, wow.
And there are pieces in there that I'm not too happy with.
Oh, okay.
For example, there is a section on functions as part of structs, which is actually what we call in C++ classes. And there is a subsection called data hiding, public, private, and class. And I find this extremely misleading because data hiding has nothing to do with access of members of classes.
Right.
And so I think the term hiding is not appropriate here. The hiding is something that applies to names in scopes, but not to the accessibility of members in a class.
Yeah, makes me think of the testing trick that some people do, which I abhor, like pound define public, private, whatever. Yeah, you don't really get true data hiding for sure with access mode in C++.
Because the point is the hiding is something that applies to name lookup. And name lookup is the very first thing that a compiler does if it encounters an entity with a name. And after the name lookup comes the overload resolution, if at all. And after that, you have decided, okay, I mean this name, and then I only see, okay, can I access it or can it not? But the name itself is visible. It's not hidden. So the term hiding is totally inappropriate here, in my opinion.
Yeah, I'm not going to argue with you. I did try to look at it a little bit from the perspective, because the intro kind of says that it's meant for people who are familiar with C, and I was thinking, okay, is this a good resource for people who are familiar with C, learning C++? I didn't really come to a strong conclusion on myself either on that.
Well, my impression is the newer parts are much more correct in this kind of sense, but the older parts probably not as much. But on the other hand, one of the very new parts is the mentioning of modules. Would you believe it? Modules are in here. And I've been reading the chapter, and I must say the whole chapter is completely wrong. It's talking about Clang modules, not C++ modules.
Oh. Okay.
So maybe this isn't the greatest resource that we should be putting out there.
Well.
Okay, besides that, this is all that I've been reading so far. The first 3 chapters and 7.2.
It's over 1,000 pages if you were to print it. It is.
Wow.
Yeah. There's a PDF download. That's how I know that. I didn't, go print 1,000 pages or anything like that. I do have ink coming tomorrow because my printer's out of ink, and I do need to print some tax documents soon, though. But I don't want to use all of my ink on printing this.
No.
Oh, well, so I guess this is a resource, but take it with a grain of salt. Except for the modules, which our expert on the show today tells us is completely wrong.
Well, it might be wrong. It might be right in terms of Clang modules, but this is not what C++ modules are.
Right.
Clang modules are more akin to header modules, but not the real modules that we have in C++ now.
Okay. We'll definitely spend more time on that in a minute here once we're done with the news.
Yeah. So speaking of the news, Jason, you want to make this last announcement?
Yeah, I'm just going to go for a little bit of shameless self-promotion here.
Why don't you do that one again?
Okay, I'm just going to go for a little bit of shameless self-promotion here. I've been doing some live streaming on my YouTube channel recently, and Friday morning my time, so it's going to be 10 a.m. Mountain Time, noon Eastern U.S. time, and 6 p.m. 1800 whatever, and Central European time. I'm going to start a live stream where I'm going to start with the pure C code base that is Doom, and try to get it compiling with a C++ compiler, and I'm going to stream for however long that happens to take. So I expect it'll probably be 4 or 5 hours of live streaming of porting Doom to C++. Now, it's just getting it compiling and getting it running, and it's not going to be like trying to take advantage of all the features of C++ because it's far too large of a code base to do that all live on the first go. Get it compiling, see if it works, maybe do some initial analysis of how that changed binary size, because it probably did. Mm-hmm. I'm not sure. We'll see. So
I've been clicking on this link and was a little bit disappointed that it didn't happen yet, so I couldn't see what you have been doing. But I'm really looking forward what your effort would result in. In particular, you mentioning the size problem, maybe because of RTTI and this kind of stuff. Mm-hmm. But probably you can just disable it and get to a similar binary size then.
And I won't disable it at all. At first, I'm just going to see what happens.
Okay.
And I don't expect RTTI to have a large impact currently because since it's a pure C code base, there's no virtual functions. So I don't expect the binary to change much. I can only think of one place where I think it might change with regard to having to put some stack unwinding code where I'm going to have to put new where there's currently a malloc. But again, I only did like a 1 hour practice run, and I didn't get anywhere close to working, and I'm going to start all over from scratch again when I do it live anyhow. We'll have to see what happens.
Which compiler are you planning on using, and what version of C++?
Clang 10, probably in C++ 17 mode. What was your question, Danny? Or comment?
The comment was maybe you will see a binary size increase just because the runtime library will pull in the stack unwinder even if you don't use it anyway.
Right. You're probably right. And I haven't even looked to see what the actual current binary size is to see, like, Even if it added 100K to it, would that even be noticeable? I don't know. I think the binary still is actually quite small right now. So yeah, it'll be an interesting experiment. Starts Friday morning.
Looking forward to it.
Yeah, so if you're listening to this episode on the day it comes out, go get on, I guess, get on YouTube. Will you be live streaming it, right?
I'll be YouTube live streaming. We'll have a link to it. So the YouTube link is live right now, and it says there's a little clock down in the corner saying when it starts. And we'll see what happens.
Very cool. Okay, so Danny, I think for the past few years, as C++ modules has progressed through the standards committee, Jason and I sometimes comment on it in the news, and every time we say, we don't really know a whole lot about modules. We haven't been following it too closely, even though we, did have Gabby on the show a couple of years ago. So you actually did a talk at Meeting C++. I think it was a beginner's guide to modules. So we thought it'd be great to have you on to educate us as well as our listeners about modules for those of us who haven't been following it that closely.
Okay. Just to make it clear, I'm not an expert on modules.
More of an expert than us, I think.
Yes, absolutely.
Maybe. But actually, I've been in the same situation as you are probably right now. About a year ago, I was thinking this module kind of stuff sounds really interesting because it will help you structure your interfaces a little bit better than you maybe just get away with using include files. And many people may have thought in the past that, okay, we are C++ developers, we are used to have much of our implementation code in include files, and we have to ship it to our customers if we want to share our libraries, and we probably don't want to do that. We want only make the parts of our interface public, which is really the interface, and not the kind of stuff which needs to be technically within the header file, which defines implements the interface. And the modules kind of thing seems to improve the situation so that you can just include these parts in your interface that you really want to export to the consumers of your code. And this is actually what modules are promising to the users of modules. It's a more principled way of implementing an interface to a piece of code, library or whatnot. And this is the main benefit of the modules, at least in the long term. This is what I would say about modules. And a side benefit from modules is that you get other advantages out of it and other benefits. And for the most part, the benefits, at least the benefit that most people are looking forward to, is an increase in compile time, as in compile throughput, I should say. So, and this is kind of a unicorn thing. It depends on the situation that you are in. If it actually would increase your compile speed, or if it actually would slow down your compile. But this is something that depends on the actual situation and the structure of your dependencies. Dependencies become a real big thing when we talk about modules, but this is something that we will probably tackle a little bit later in our conversation.
Yeah,
go ahead.
It sounded like you were also saying that we might get true information hiding here, or data hiding, like we were just talking about in that.
Actually, yes. And this data hiding stuff comes from the simple fact that a module is no longer a piece of code that is stitched into your translation unit like a regular include file does, but a module is something that is compiled on its own. And as we all know, if we have symbols, names in your translation unit, these names are not visible outside of your translation unit. The only thing that becomes visible are the symbols that are generated from the names.
Mm-hmm.
So actually, a module being a completely separately compiled kind of thing hides everything what's in there, and you explicitly say what part of all the names that exist in your module become visible to other translation units. So this is where the hiding comes from.
Okay.
In the include file compilation model, as we are used to, has actually no real means of hiding anything. You can make names not visible from a certain point in your program, but you cannot completely hide it. This is the visibility of names in a translation unit depends on where you are in the compilation process, but you cannot completely hide it because at some point you are in a scope that a name becomes visible.
Mm-hmm.
So this is the main benefit here, and this is in fact this is everything what modules are about. It's the visibility of names.
Okay.
Everything else is about the same as it has been ever since. So what you can do with the modules is you say you have a translation unit which you designate as a module, and you say, okay, this name and this name and this name and this name becomes visible to other translation units. This is all what you need to actually know about modules. Everything else is just technical stuff.
So you said in some cases it might give you better compile throughput, but you said in some cases it might actually make compile times worse? This
is true, yeah. But we have probably to dig a little bit into modules. Typically a module consists of an interface unit and an implementation unit at its minimum. And this resembles the kind of dichotomy that you have in, say, a library, where you have a CPP file that you implement the library and a header file that you have all the interface stuff in. And what you typically use as the interface include file becomes a translation unit on its own. And this is the so-called module interface unit. So
okay.
Being a translation unit, it will be compiled separately, and the stuff that's going to be exported from the module interface becomes something similar to a pre-compiled header. This is something that a compiler can later on use to get access to the exported interface of your library. So this means you have a dependency, a compile dependency there. Before you can use a module, you have to compile the module interface first, and then you can consume the compiled interface.
Okay.
Rather than just compiling the include from the library interface during the translation unit where you consume the interface, you have to wait for the compiled interface to exist. So it depends on how your dependency chain is structured in your project. So if it's a deep chain, you have a time dependency rather than just an include dependency. Typically, you can say, okay, each translation unit can compile separately on a different machine if you like, and as long as you have the include files available, the compilation process just goes straight ahead.
Okay.
You compile one translation unit and that's it. And with modules, you have at least to have the compiled module interface available to consume a module.
Okay.
So this compiled module interface is a compilation dependency. So in terms of wall time, actually the compilation may take longer than it has been before. But on the other hand, if you reuse your compiled module interface unit many times, you can actually get a speed up.
Okay. That makes sense.
It depends on your build machine. If you have infinite resources, then the embarrassingly parallel compilation module with include files is probably faster in terms of you look at the wall clock at the beginning of the compilation of the whole program and the finish. But if you're a typical developer, you're probably much faster with using modules. In particular, if you don't compile your whole project every time from scratch, because you can cache your compiled module interfaces and then you just reuse them afterwards. And in this case, even deeply dependent, deep dependency chains may become even faster to compile than with include files. During my talk, I've been giving an example from our code base where a simple compilation of the interface of a library of ours took 1.5 seconds using the include and 60 milliseconds using the compiled module interface. So it's quite a speed up if you have the interface module compiled available.
Right. So is the main gain there not having to reparse tens of thousands of lines of header files or something?
Exactly. In this particular case, it has been over 900 files, which would be hidden behind this single include file. And this is, you can see the numbers in the PDF. I'm pretty sure the PDF will be in the show notes. So
if you want it to be,
you can do. And you will see the actual numbers that I've been experiencing. Just to mention it, I have it here. It's about 500,000 line versus 5 lines.
Wow.
So you mentioned PCH, and now I'm curious. Do you see in a post-modules world where everyone is using modules for everything that there will no longer be a use case for precompiled headers?
I do. Actually, I think if we start software from scratch, you really should think about not using include files at all. Only use modules, and if you do so, your compilation process will be much, much faster than if you do proper caching, of course.
Right.
But to be in this situation, there is probably much more time needed just to have all the tools available to do so and really take advantage of the benefits of modules. But we're not there yet.
Right.
What about header-only libraries? How are those going to change in a world with modules?
Well, actually, it depends on what your expectation is. Mm-hmm. If you just want to make it available for immediate rapid consumption as a compiled module interface, just go ahead and compile it as a translation unit. There's a feature in C++20 which is called header modules. You just give a magic incantation to your compiler and it would compile your header as a translation unit and spit out an object file and the compiled module interface. Every entity with external linkage in your include file or header-only library becomes available without any change to your source.
Okay.
So just use it. This is actually what the modularization of the standard library is about. The compiler vendor will pre-compile the for example, vector or whatever it might be, or string, and maybe it would put some of these parts together into a larger module, and then it's ready for consumption. And in effect, it's a pre-compiled header, which is totally compiled and is no longer dependent on the ordering in your translation unit as we have been used to in our current translation model. This is the main benefit from compiling a header-only library as a module. Anything that comes out of the compilation process is fixed. So the source code of the header-only module is no longer susceptible to symbols that are defined before, maybe macros, and they are no longer susceptible to names which are visible because of include files that exist literally before the header-only library. So, for example, if you have a name that is quite popular, it might turn out that the same name exists and could be found by dependent lookup, and so your overlay set match may become larger, and you may end up with a better match from a different library or source code that I had before, so that the meaning of your library becomes different from what the library author has been intending. And this is one of the benefits of modules. You compile them on your own, and the environment of the compilation is totally fixed. So this has something to do with definitions. This has something to do with the ordering of includes, and it has something to do with a compiler flags which might affect what's actually compiled in there, how the layout is. And this is something that you really will benefit from, the much lower chance of getting into ODR violations because of differences in compiler flags or overload sets and this kind of thing.
So if I compile my module with like the Unicode flag set on Visual Studio and then try to use it in an executable that doesn't have that flag set, that's something the compiler would catch? Or
actually, in case of Visual Studio, it would, because Visual Studio has Visual C compiler has a check in the compiled module interface that allows the compiler to compare the options in effect during the compilation of the module interface and the compilation of the current translation unit. So if you have differences in there, the compiler would reject it.
And is that something we expect all compilers to do, or?
Well, if it comes to me, I would expect it, but I'm not sure if it really
if
does.
It's required?
It's not required.
Okay.
The standard doesn't say anything about the compile environment in this regard.
Okay.
But it's actually good habit to do so.
Oh, I'm sorry, if you don't mind, make a quick note on something earlier, because you mentioned including standard string. And for the sake of our listeners, I don't think everyone appreciates that standard string is not a concrete type. It is a template that is a basic string on car. And so to your point that, yeah, even something as simple as string, having these headers precompiled or something like that could, again, also, you mentioned it with vector, which is, I was just saying for the sake of our listeners, in case they didn't catch that, yeah, potentially saving a bunch of extra parsing and template instantiations and such.
Well, actually, this turning into modules and header modules, in this case, applies to every standard C++ header, which is not a wrapped C header, and this is guaranteed by the standard.
Okay, so it'll be everything for sure.
So if your implementation doesn't come with precompiled modules from the standard library, you can do it on your own. as long as you know the magic incantation to do so.
You keep saying the magic incantation. It makes me wonder, like, so you're clearly using this on your code base right now at work?
No, we don't.
Oh, okay.
The problem is currently compilers are struggling with complicated code. So I did my experiments, and in the PDF that the readers will probably see in the show notes, you will see what the Visual Studio compiler was giving me as error messages, and it was kind of a struggle to make, for example, Boost libraries be ready to be consumed in a interface module.
I don't understand. It's not like the Boost libraries are complicated.
I'm not sure what it's been.
Just being sarcastic.
Yeah, it took me quite a while to figure out what to do about this situation, and at least I managed to make Visual C++ compile this thing. Otherwise, I wouldn't have anything to show in my talk. But Clang 10 wasn't able to compile this kind of stuff so far. So there's a long way to go with compilers. At least this is my experience so far.
Uh-huh.
I'm really looking forward to retesting all this kind of stuff with Visual Studio 16.5 out right now. There's been a blog post on the Visual Studio blog where Cameron was saying that they have implemented virtually everything that is in the C++ standard. Well, the upcoming standard, it's not really inked, but yeah. So I will see how far they have come with their implementation right now. At least feature-wise, I've been looking at my comparison table. Visual Studio is quite far in this regard.
It doesn't surprise me, given who works there and is interested on this topic.
They actually have been talking to Gabby in Prague about the current situation of the modules implementation in Visual Studio. Mm-hmm. And he says, yeah, he's aware of there is some pieces which cannot be compiled into a module interface unit so far. Something the const export kind of stuff will give you nice messages like, sorry, not implemented yet. Yeah.
Well, that's better than a cryptic error. At least you know exactly why it failed.
Yeah, this is right. But well, actually, my first try on my first take on modules has been I wanted to make the FMT library into a module because I'm quite familiar with the FMT library. I've been doing some of the reference implementation there, and it failed spectacularly. I've been trying for a couple of months to make it work, but every dirty trick I've been using, none of this would work out. So I had to turn into something less challenging. This is something that I've been using this is the reason why I've been using something from our code base here until it came to Boost, yeah.
So is there currently any build system support that you're aware of? I mean, does CMake have any awareness or whatever?
Well, I've been looking into CMake, and there has been a Reddit post just a day ago or so, where one of the CMake developers said, yeah, they're working on it, but it's not in the mainline. And the only really module-aware build system so far that I know of is build 2 from Boris Kolpakov.
Okay.
And it was designed with modules in mind from the first place.
Oh, that's cheating.
Well, actually, he has been giving some talks during the past couple of years on modules. So people who are interested in it should look up his name and watch these videos. And maybe for for experimenting with modules, which is highly recommended, it's probably a good idea just to use build2 for these kinds of experiments. Unless you use, for example, a simple make, or you maybe just use a batch file with all the compiler invocations in there just for the very first experiments. Don't bother to figure out how your build tool would compile a module. You can do it in Visual Studio. It has preliminary support in there, but this is not really baked so far. At least it's not up to the task to take really advantage of the more advanced parts of the module specification. Okay. If you're sticking to simple modules, this is the kind of stuff that's specified in the modules TS and out for a couple of years now. This can be done with Visual Studio using the MS build system, and everything beyond that is something that needs lots of thinking of and implementation in MS build and the other build systems as well. I'm doing my own add-on to MS build just to make my compilation, but this is not something that can be used by anybody else. This is really tricky stuff.
That's okay. So I'm curious how you originally got interested in modules. If most of your background is in, like, it sounds like lower level work in electrical engineering and VHDL and all this stuff. Like, why modules?
Well, actually, it's super simple. I wanted to propose a talk to Meeting C++. This is all that's it about. And I said, okay, this is something that I want to learn. I'm really interested in this kind of stuff, and let's propose a talk. It probably won't get accepted at all, and it was actually quite popular.
That's great.
So if I understand your timeline, you proposed a talk, it got accepted, and now you found yourself hacking on build tools.
Right.
Okay. Sounds about right.
And figuring out how to invoke, for example, ClankCL on Windows just to compile a module. Mm-hmm. This is something that's even more challenging than extending MS Build.
You know what? You just made me think of something, because, I mean, ClankCL is binary compatible and command switch compatible with CL, theoretically, right?
Right.
So they're also going to have to support, eventually, Microsoft's module format, as well as their own.
Well, today they don't. So the compiled module interface from Clang is totally different to the compiled module interface from Visual C++. If you look at the binary format of these compiled module interfaces, you will see a big difference in there. As far as I know, the compiled module interface from the Visual Studio compiler is a descendant of the work from Gabby and Bjarne during their tenure in Texas A&M University.
That was a long time ago.
Yes, this is really a long time ago. And they had a science project there. They've been looking into how you can represent the semantic content of a C++ program condensed to something more palatable to a compiler, rather than parsing text, which is more meant to be read by humans.
Right.
And this is the background and the foundation of the file format of the compiled module interface in Visual C++. At least as far as I know, this is the information that I got from the compiler team through the grapevine.
The unofficial answer.
Yeah, and actually this kind of stuff is available on GitHub if you want to look at it. And it's, well, there's a pull request from Gore, and there's hardly anything besides that what's been going on in the original study, as far as I know. So I think the actual IR representation in the implementation of Visual Studio C++ is quite different now from that what you've been shown on the GitHub repository from Gabby.
Okay.
Okay. Another question our listeners might have is if they're, C++ library authors, maybe targeting some library with C++17, is there anything they should do to prepare for a world with modules with their library?
Yeah, actually, there's one thing that you really need to be aware of. A module, even if it has a name, it doesn't comprise a new namespace. So if you want to be sure that your library is prepared to become a module later on, make sure that all the stuff that you export from your library is enclosed into a namespace on your own. Maybe it's a nested namespace, and it's probably a good idea and actually recommended by the SG15 study group that the namespaces that you put in all your exported entities should resemble the naming parts of your module's name. And this should also resemble in some way the file structure in your project, so that you have a kind of correspondence to make it not too hard for your build system to actually build your module and to consume your module, and to not run into possible name clashes. Name clashes can also happen even with modules if your exported entities share the same namespace.
Mm-hmm.
Mm-hmm.
So modules are not namespaces, and users of modules need to be aware of that. Because if you look at the expectations of users, at least this is the stuff that I'm reading from users on Reddit, for example, or Slack. People expect a module that has a name to establish a namespace of that name, and this is not the case. Namespaces are completely orthogonal to modules. Actually, namespaces can be something that spans multiple modules, even if the modules have different names.
Right. I like this. So it sounds like the main point is keep your code cleanly namespaced.
Actually, yes. And this is so important in your design of your interfaces. And if you do it wrong, modules wouldn't help you in any way.
Right.
I feel like my favorite takeaway from what you just said is it also means you can't use macros anymore since they don't respect namespaces.
This is true, with one small exception. And the exception is header modules will taint your translation unit. So, for example, if you have a header file which you turn into or compile into a header module, all macros which are part of your include will exist even after the import of your header unit.
Okay.
So in this sense, they taint your translation unit.
So we shouldn't use them then.
Yeah, but this is true, and you should strive for not leaving macros behind. But in some cases, macros are part of your interface.
Right.
So in this case, a header unit is actually a good thing to have at hand. So you can take the benefit of pre-compiling the kind of stuff and not being susceptible to other macro definitions or other names which would increase your overload set and this kind of stuff. But you can still export modules as part of your interface.
Okay.
So you have everything you need to structure your existing interfaces. If you have, for example, if you would think about modularizing Qt, this is something that I'm looking into. And Qt has a ton of macros which are part of their interface. You can only
Right.
go with header units in this case.
Okay.
And it's actually a good thing.
Right.
Otherwise, you wouldn't have any chance to use Qt in a modules world and as a module as itself. And this is really something that I'm looking into. Just
Is that
saying.
something?
Yeah.
Sorry.
Go ahead.
Is that something you're looking to like submit back to Qt to help them modularize?
Well, I'm actually just a user of Qt, and actually a really old one. We are still on 4.8.
Okay.
So hardly anybody is interested in something that's tailored to this really old kind of stuff. But we didn't have any reason to use a newer version of Qt so far.
Right.
I can compile it with any modern compiler, so.
I just found myself wondering, when was Qt 8 released? It looks like 4.8 was 2014, maybe?
Maybe even older.
Maybe older. It's hard to like get a quick answer to that because there's been so many patches and whatever to it. Yeah.
Yeah, I have additional patches on top of it to make it compile on Studio 2019.
2012?
Okay.
Sorry, I just became completely... Yeah, it looks like 2012. Sorry, I'm done.
Okay.
This is the reason why we can compile our source code with any compiler since 2010.
Wow.
We support really old code.
Wow.
Yeah.
But
So I kind of want to come back to this timeline here that you submitted a talk to Meeting C++, and then once it was accepted, you had, it sounds like, a lot of work to do.
yeah, I couldn't believe it. Wow, I've been on vacation in France. I got the information, your talk is accepted, and I said, no, please don't.
So do you recommend that, though, to other people who are thinking about giving conference talks?
Totally.
Okay.
Totally. You put some pressure on yourself just to make this talk happen. And you learn a lot. Actually, this kind of digging deep into C++ made me become part of the C++ committee.
Well,
Oh, awesome.
that's quite the journey then, yeah.
Yeah. And this is the reason why I'm so much deeper into knowing what the core language actually is giving to us, and what kind of improvements should probably be there. But I'm totally a novice to the standards committee, so I'm just learning.
Well, Rob and I have never been to a standards meeting at all. I'm thinking about going to Kona because who doesn't want to go to Hawaii, I guess. But we'll see.
Well, if you like to be quarantined for a week, go to Kona.
Well, hopefully, I mean, they're still,
Well,
what is it, 10 months away, so.
I'm not talking about a human Marburg situation here. I'm talking about you're totally absorbed. You won't probably see anything from Hawaii. This is the reason why I probably will not be on any meeting in the US, because it's big travel, and just seeing meeting rooms doesn't make much sense to me. So I'm really looking more into the online meetings which are happening right now.
Oh, okay.
So November was your first conference. Was that your first conference talk?
This is the second one. The first one has been on the FMG library a year before.
Ah. So we expect that talk should be on YouTube someday, but it is not yet.
Not yet, as far as I know. And
Okay.
Jens is actually also absorbed with other kind of things. I'm not sure why the video isn't been put out yet. Let's see
Okay.
how things turn out. But at least the conference slides are in the PDF that I've mentioned before.
All right.
So we'll put those in the show notes.
And maybe if we get a notice that the video has been put up, we can update the show notes later as well for a link to it.
Sure.
Okay. Well, it's been great having you on the show today, Danny.
Thanks for having me.
Thanks for
It
coming.
was a nice experience.
Yeah.
It was fun.